Good morning, everybody. We're going to try something a little new with an ed puzzle today. This is just a review, kind of get things started on what we did last year, I guess it would be. Happy New Year. So, we're going to look at three questions that I have using the normal. You have a speed limit on a road in New Jersey, 65 miles per hour. Driver on the road drive on average 63 miles per hour, standard deviation of 3 miles per hour. Find the following probabilities. We want to know what's the probability a random driver is speeding. The driver is going 59 miles per hour or less. And a random driver drives between 59 and 65 miles per hour. So we got our greater than, because speeding would be greater than 65. So always start by trying to figure out what we're trying to do. And then 65 miles per hour would be this one. This one's obviously less than 59 miles per hour less, and this is my between. So those are the three that we were trying to figure out how to do when we left last year behind. All these use this formula where you find your z, which is equal to x minus mu. This is mu right here. That's the mean over this is sigma, the Greek letters, which represents the standard deviation. So for all these, we're going to be finding z equals x minus mu over the mean, and then we're doing something a little different after we look up the z values on the z chart. So let's figure out what the mean is. Our mu for this problem is not 65. The drivers on the road drive on average 63. And the standard deviation for this problem, it's always good to write it out so you don't mess up and put 65 instead. Standard deviation of 3. How do I know all this? They told me. By they, I mean the little people in the head. Stop talking to me. Stop talking to me. No. And the problem itself, too. Either one, I would go with the problem. Probably is better than the people in your head. So what do we got to do here? We're going to do, first we want greater than. So if you remember, for greater than, we're going to do 1 minus the probability z that we have x is less than 65. First, we got to figure out what's the probability x is less than 65. That's what our z chart. Ta-da! Hold on, that's for math. That's what z chart gives us. So I'm going to have to transform this x value of 65, but then it's more than meets the eye, into a z value. So if we can look at our formula up here, if I want to find z, I just need this formula up here. X 65 is x. Minus the mean. I don't need mu the mean. What I need is the actual mu the mean, which we said was 63, and divided by the standard deviation. So it's just a matter of plug in once you find out what the values are, which was 3 in this case. All the problems are done the same way. Put your values in. This is going to equal 2 divided by 3. Everybody knows in most places, except in London on Tuesday, is 0.66666666666, but that's an evil number. So we'll just go to 67. So we round that up. I'm going to take a look at the z chart. I want a positive, so this left side's out. I want 0.6, and I rounded this up 7, would be 7486. 7486. So I'm going to put that under here. This is 1 minus 0.7486. 3. So probability x is less than 65 is 0.7486. So if I hold things 1, I subtract 0.7486 from it, I get the probability that z is greater than, or probability that x is greater than 65, or they're speeding, right? That's what they mean if it's speeding. It would be 1 minus that, which would be 0.2514. Voila, it is done. That's the first thing. This one's done in quite the same manner, but we don't need the 1 minus. So I'm going to take the z chart again. or take the z-score formula. This is why it's good sometimes to do your stuff in Word or Excel is even better. All I'm changing here is the x. X is 59. My mean stays 63 and the standard stays 3. So that would be negative 4 divided by 3, which in all places except for Zimbabwe on a Thursday would be negative 1.333333333333333333333333. Well, I think you get the point. Let's just go to 1.33, and then this way we can round it. Let me take out my handy dandy Z chart that I carry around with me everywhere. Negative 1.30, 1.31, 1.32, 1.33, 0.0918. 0.0918. I just keep repeating that to myself. 0.0918. So the probability that somebody is going under 59 miles per hour on this particular road with each particular mean, that particular mean and standard deviation would be 0.0918 or 9.18%. What about in between? In between. Well, luckily for us, I picked two values that we've already used. So to do in between, I'm going to find the larger value. I'm going to take the probability that x is less than 65. That's going to go from 65 all the way back. And I'm going to subtract out the probability that x is less than 59. Now, if we did not have, or if we have not already looked these up, we would have to convert these into z values, and then it's more to meet the I transform them. But we already did that. Right? I did 65 up here. That was 0.67. I found that probability. That probability for 65 was right up here. I already did this. You guys hopefully followed along. So that probability is 0.7486. Minus, we just did x is less than 59, which was 0.0918. And we subtracted 2. That would be 8. That would be 6. That would be 5. And that would be 6. Pretty good, right? 6 carried 1. Let's see. So 6 carried 1, 8, 5 and 9, 4 carried 1. Yeah, looks good. So this is what you'll be doing today. There's 3 different kinds of questions. Less than, you just find the z and look it up. Greater than is 1 minus what you look up. And in between, you find them both and subtract them.